Welcome to our exploration of a fascinating topic. Why do astronauts float in space? Many people have seen images of astronauts drifting effortlessly inside their spacecraft, but the reasons behind this phenomenon are often misunderstood. In this first part of our five-part series, we'll break down the basics of floating in space and set the stage for our deeper dive into the science behind it. To begin, we need to understand the environment in which astronauts operate. While we often associate space with the vast emptiness beyond our atmosphere, it's crucial to note that space is not completely empty. Rather, it's a vacuum with very low pressure. This means there are very few particles present, making it a unique environment for anyone who ventures beyond Earth. However, the gripping question remains. Why do astronauts appear to float freely as if they were in a dream? The key to understanding why astronauts float lies in the concept of gravity. On Earth, we are constantly pulled towards the ground due to gravity. However, as we venture into space, gravity still exists, but its effects change depending on our distance from a massive body, like Earth. Many think that once you're in space, there's no gravity at all. In reality, even in low Earth orbit, where the International Space Station resides, gravity is only slightly weaker than it is on the ground. In fact, astronauts are not floating because there is no gravity. They are floating because they are in a state known as free fall. When a spacecraft is launched into orbit around Earth, it travels at a very high speed, balancing the gravitational pull that tries to bring it down. This balance creates a condition where both the spacecraft and everything inside it, including astronauts, are falling towards Earth but are also moving forward so fast that they keep missing it. This creates the sensation of weightlessness, where astronauts appear to float freely. As we move forward to the next part of our series, we will delve deeper into the specifics of freefall and how it affects daily activities for astronauts aboard the International Space Station. We'll also discuss the unexpected challenges that come with living and working in a weightless environment. So, stay tuned as we continue to unravel the mysteries of life in space, making sure to clarify why astronauts float, how they manage their tasks, and what it means to live in such a unique setting. Keep your curiosity alive, and we'll see you in the next part. Welcome back to our exploration of why astronauts float in space. In the last segment, we laid the groundwork by discussing the concept of gravity and how it works on Earth. Now, let's dive deeper and explore the unique environment of space and how it affects everything from astronauts to their equipment. When we hear about astronauts floating, it's easy to imagine that there is no gravity at all in space. However, this isn't entirely accurate. In fact, gravity exists in space. It's just weaker than what we experience on Earth. For instance, even at the height of the International Space Station, gravity is still about 90% as strong as it is on the ground. So why do astronauts appear to float? The answer lies in a phenomenon known as free fall. Imagine being in an elevator that suddenly loses power. It drops. When you're inside that elevator, you experience a sensation of weightlessness because you and the elevator are falling together at the same rate. This is similar to what happens with astronauts on the International Space Station. The station is constantly moving forward while simultaneously falling toward Earth. This combination creates a state of free fall, meaning astronauts inside feel weightless and float around. This free fall condition allows astronauts to move freely in all directions. They can glide, spin, and flip with ease, creating an environment that can even make daily tasks a bit of a challenge. For example, drinking water or eating can be quite an adventure, as floating food and fluids can quickly escape into the cabin. Astronauts have to use special containers and equipment to prevent their meals from making a mess. As we think about how astronauts train for this unique environment, we see how preparation is critical. They undergo extensive training on Earth to simulate the weightlessness of space. This is often done in large swimming pools, like NASA's Neutral Buoyancy Lab, where they can practice their tasks underwater. This helps them adapt to the sensation of floating before they actually experience it in space. In our next part, we will delve into how living and working in a weightless environment affects the human body. You might be surprised to learn about the changes that happen in an astronaut's body during long missions in space. Stay tuned as we continue to unravel the incredible mysteries of the universe. Remember, The journey of understanding space is full of fascinating facts that connect us more deeply to our world and beyond. See you in Part 3. As we continue our exploration of why astronauts float in space, it's essential to understand the role of gravity. Many people think that once you leave Earth, there's no gravity at all. However, that's not entirely accurate. In fact, gravity exists in space, but its effects are significantly reduced as you move further away from the Earth. The International Space Station, where many astronauts work and live, orbits Earth at a height of about 250 miles. At this altitude, gravity is still present, but it's about 90% as strong as it is on the surface. This is why astronauts float. They are in a state of free fall. Imagine dropping a ball. It accelerates toward the ground due to gravity. In the case of the space station, both the station and the astronauts inside it are falling towards Earth. But because the space station is moving forward at a high speed, it keeps missing Earth. This creates what we call microgravity, or the sensation of weightlessness. To put this into perspective, think of a roller coaster. When you reach the top and plunge downwards, you experience a moment of free fall. This feeling is much like what astronauts feel every day in space. Although they are technically still under the influence of gravity, they don't feel its effects because everything around them, including their spacecraft, is falling too. This unique situation allows astronauts to conduct experiments and experience life in a way that simply isn't possible on Earth. They can float around, perform tasks in 3 dimensions, and become accustomed to a different way of experiencing their surroundings. Floating can even be fun, giving astronauts a chance to play and engage in playful science experiments. However, it's not all about fun and games. Understanding how microgravity affects their bodies is a crucial area of study. Astronauts face significant changes when they spend extended periods in space, such as muscle and bone loss. Their bodies adapt to this environment, and scientists continue to research how to keep astronauts healthy for long-duration missions, especially as we aim for long trips to places like Mars. In the next part, we will delve into some of the incredible experiments carried out by astronauts in microgravity and how their findings affect life back on Earth. So stick around as we explore the fascinating world of space science and its impact on our everyday lives.